Okay, we're going to do applications of derivatives, part 2. Okay, so this is just some more examples. Okay, so example 1, we're going to find the rate of change of, let's split this into different sections. Okay, so part A, f of x equals 6 over x at x equals 3. Okay, so the first thing we need to do is to prepare to differentiate. Okay, so that is 6 over x to the power 1. I'm going to use that rule, a to the minus n equals 1 over a to the n. Bring that up, and that's 6x to the minus 1, and then differentiate. Bring the power down, multiply, take 1 away from the power. Bring the minus 2 back down, and I've got minus 6 over x squared. Now, why am I making the move from there to there? It's because I need to make a substitution. So x equals 3, let's sub that in. So it's going to be f dash 3 equals minus 6 over 3 squared. That's minus 6 over 9, which will simplify down to minus 2/3. Okay, part B, we've got f of x equals 4 root x plus 6x, and we're finding the rate of change at x equals 16, so prepare to differentiate to get going. So 4 root x is 4x to the half plus 6x, I can now differentiate. A half times 4 is 2, and then take 1 away from the power. A half take away 1 is a half, take away 2 halves, that's minus 1 half, and then if I differentiate 6x, it's 6. Okay, I'm now wanting to sub in x equals 16, but I want to do it into a positive power and preferably with the root sign. So that's 2 over x to the half plus 6. Reintroduce the root sign. F dash to x is 2 over root x plus 6, and I now can sub in 16. F dash 16 equals 2 over root 16 plus 6, and that's 2 over 4 plus 6. Okay, so 2 over 4 is a half, so a half plus 6, we could write that as 13 halves. Okay, example C, f of x equals x cubed minus x over x squared, and we're looking for the rate of change at x equals minus 2. First thing I need to do is split the thing up. X cubed over x minus x over x squared. Okay, use my second row indices. When you divide, you subtract the powers. So, what number's there even though you can't see it? 1. What number's there even though you can't see it? 1 again. So 3 take away 1 is 2, x squared. And then 1 take away 2 is minus 1, x to the minus 1. I can now differentiate the thing, and it'll be 2x. Minus 1 times minus 1 is plus 1x to the minus 2. Tidy the thing back up, reintroduce the positive power. 2x minus, what number's there even though you can't see it? 1, so it's definitely there. Bring this back down, and it's 1 over x squared. I now sub in minus 2, and that will be 2 lots of minus 2 minus 1 over minus 2 squared. That's minus 4 minus 1 over 4. So it's minus 16 quarters, minus 1 quarter is minus 17 quarters. Final answer. Okay, example D. F of x equals 3 over root x, and I want to find out what's happening at x equals 9 when I differentiate. So first thing I need to do is to prepare to differentiate, so that'll be x to the half. Still preparing to differentiate, and now bring that up, and that's 3x to the minus 1 half. I can now differentiate. Bring the power down, multiply, take 1 away from the power. Minus half times 3 is minus 3 over 2, x to the minus 3 over 2. Okay, then I bring that back down at the bottom, changes power to positive, and I've got minus 3, that stays up there, 2 stays down there, x to the positive 3 over 2. Now I don't try and attempt to sub in x equals 9 until I reintroduce the root sign, so let's do that. F dash to x equals minus 3 over 2 lots of the square root of x cubed. Okay, now I can sub in f dash 9 equals minus 3 over 2 lots of the square root of 9 cubed. It's minus 3 over 2 lots of, what was the square root of 9? Square root of 9 is 3. What's 3 cubed? Cubed is 27. 3 times 3 times 3. And that'll give me minus 3 over 54, which can simplify down to minus 1 over 18, final answer. Okay, now you're going to have a go at these ones. So f of x equals 3x minus 1 over x squared, find the rate of change at x equals 2. Second one's got a real life context. The distance of a rocket is calculated by the formula distance equals 4t cubed. Calculate the speed of the rocket after 8 seconds. Remember that the speed is a rate of change of the distance, and which rate of change that's telling you to differentiate. So your two things is well, first of all, with this one, preparing to differentiate, sub it in, and with this one, differentiate and sub in.